All right, we're going to look at a challenge problem and a real-world connection problem related to systems of equations, and particularly solving systems by graphing. And here we'll make a graph, and we'll also make a table to start us off, though. So here's a scenario. My two sons each have a savings account, and back in 2010, my older son Owen had saved up $250 in his account by then, and he's able to put away $60 a year. Okay. In the same year, at the same time, Cedar, my younger son, had only $100 saved up, but he's saving about $75 each year. Okay, and so our task here is to make a table and graph and estimate when Cedar and Owen will have the same amount of money saved. And it looks like Cedar has less right now, or back in 2010 he had less, but he's trying to catch up because he's saving a little bit more each year. All right, so I'm going to start a table first, but let's get our variables set up, and let's let x equal the number of years since 2010, and that'll just make our numbers a little bit simpler, a little bit lower, easier to work with. And let's let y equal the money saved for each kid. Okay, so we're going to make a quick table here, and I don't know how long it's going to take them to have the same amount of money, but let's just see how it goes. So we'll count by years here. And let me actually be more specific here. Let's have y be the money saved, but we need a y for Owen and we need a y for Cedar. So we need more than just the two columns in our table. And so, okay, so Owen started out with 250 and he's gaining 60 each year. So let's just count up by 60s. That'll be 310, 370, 430, 490, 550. And I don't honestly know how far I need to go, right? But we'll see how long it takes. Let's just go up 10 years, 790. Okay. Cedar's saving up 75 each year, and he started with only 100. So 175, 250, 325, 400, 475, 550. It's taken us a while here. Let's see. 610. No, I did that incorrectly there. 550, 625, 700, 775. Oh, it looks like they're starting to get caught up. Let's add another couple rows to our table here. This is 850. This would be 910 for Owen. 775 plus 75 is 8. Okay, it looks like they caught up. Okay. And then Cedar's going to be ahead. I hope I did all that math correct. We're going to check it when we graph it up, make sure it all stays in a straight line. So I think you can see that they have the same amount of money here. Okay, and then assuming the pattern stays the same, Cedar will just keep on moving ahead of Owen and getting farther and farther ahead. So let's do a graph, and all of our values are positive, so we only need a graph in our first quadrant. And we can call this year, and we can call that money. Okay, and so we're going to do a separate line for Owen and a separate line for Cedar. And I think the easiest way to graph this, well, let's set up a scale first. We'll go up, each square will be 1, but I'll only label every other to make things a little bit more efficient here. Looks like we have to go up to about 1,000, so I think we'll get there if we go up. Again, every square could be $100 here, but I'll just label every other. And for Owen, let's color coordinate a little bit. So I'll have Owen's be in blue, and I'll have Cedar's be in red. How about? Okay. So let's graph Owen's blue line. He starts at 250 right here. And the easiest way to do this, I think, rather than just going up by 60s and sort of applying the slope to the line, let's just plot the last number. Let's plot 12 and 910. So that's going to be right about there. and we can just connect these points with a line. Okay? And again, we want to try to be as precise as we can with this. We're trying to get in, we already know what the answer is from the table, but we're trying to see if we can use the graph to get an answer as well. All right, so next one is graphing Cedar's numbers. He has only $100 at the beginning, and he's up to $925 in year 12. So that's a little bit higher, right in there. Oops. Try to zoom in and get that 925 in as careful as we can. Okay, so let's go ahead and graph this guy up. And it looks like they cross. So where do they cross? They cross, as best as we can tell, right in there somewhere. And so I picked this problem on purpose to highlight a couple different things. One is so we can sort of visually see what we're trying to solve when we solve a system of equations. But the other actual reason here is it's going to be challenging to get a very precise answer when we're graphing, okay? So it looks like this is where's that intersection point? Maybe right there. It's a little bit hard to tell, okay? Is it right there or not? Where in that zone is it? But it looks like it's around 10.5, maybe around 11, and it looks like it could be around $820, $850, somewhere in there. Okay, and from the table we know that they intersected at 11,850. So that is the correct answer. We know that from the table. But I just want to reinforce that sometimes it's challenging to get an exact precise answer just from the graph. So anyway, it looks like they'll have the same amount of money next year, right? Because year 11 will be 2021, and I'm filming this in 2020. Okay, so we'll follow along Owen and Cedar's progress, and we'll see if they really do have the same amount of money. All right, that's a good place to stop right there.